Today, we are learning about distance and displacement. Many students think they mean the same thing, but they are actually different. By the end of this lesson, you will clearly understand the difference between distance and displacement. Let us start with distance. Distance means the total path traveled by an object. In this example, the person moves from point A, follows a curved path to point B, and then moves back to point A. For distance, we do not care whether the path is straight or curved. We only care about the full path the person traveled. So, distance is the total length of the path covered. Here, the red path shows the full movement of the person. This is what we measure when we talk about distance. That is why the measuring tape is shown here. Distance only cares about how much ground was covered, so even if the person returns close to the starting point, the distance is still the total path traveled from beginning to end. Displacement is the shortest straight line distance from the starting point to the final point. Displacement also has direction, such as north, south, east, or west. Distance follows the complete path while displacement uses the shortest straight line. Now, let us look at an important example. The person starts at point A, walks to point B, and then returns to point A. Although the person has traveled along a path, the final position is the same as the starting position. The distance is the total length of the journey from A to B and back to A. However, since the starting point and final point are the same, the displacement is 0. Let us quickly summarize what we have learned. Distance is the total length of the path traveled. Displacement is the shortest straight line distance from the starting point to the final point, and it must include direction. Now that we understand the difference between distance and displacement, let us solve some questions together. These examples will help you understand how to calculate both quantities correctly. Let us solve this example. A boy moves 4 meters from point A to point B, and then 3 meters from point B to point C. Find the total distance traveled and his displacement from A to C. Pause the video if you need more time. I'll reveal the solution in 3, 2, 1. Now, let us solve it. The total distance traveled is the path from A to B plus the path from B to C. So, distance equals 4 meters plus 3 meters, which gives 7 meters. The displacement is a straight line distance from the starting point A to the final point C, that is 5 meters. Therefore, the total distance is 7 meters while the displacement is 5 meters. Let us consider another example. A car moves 10 kilometers east in a straight line. What are the distance traveled and the displacement of the car? Pause the video if you need more time. I'll reveal the solution in 3, 2, 1. Distance is a total path traveled. Since the car travels 10 kilometers, the distance is 10 kilometers. Displacement is the shortest straight line distance from the starting point to the final point, including direction. The car moves 10 kilometers directly east. Therefore, the distance is 10 kilometers while the displacement is 10 kilometers east. Let us solve another example. A car travels 30 kilometers north and then 40 kilometers west. Find the total distance traveled and the displacement of the car. Pause the video if you need more time. I'll reveal the solution in 3, 2, 1. Let us solve the question step by step. First, distance is a total path traveled. The car travels 30 kilometers north and 40 kilometers west. Therefore, the total distance is 30 plus 40, which equals 70 kilometers. Next, we calculate the displacement. Displacement is the shortest straight line distance from the starting point, A, to the final point, C. The two movements form a right-angled triangle. Using Pythagoras' theorem, displacement equals the square root of 30 squared plus 40 squared. That is the square root of 900 plus 1,600, which is the square root of 2,500. Therefore, the displacement is 50 kilometers in the northwest direction. Here's a challenge for you. A ship sails 60 kilometers north, 80 kilometers east, 20 kilometers south, 30 kilometers west, and finally 40 kilometers south. Find the total distance traveled, the magnitude of the displacement, and the direction of the displacement. Pause the video if you need more time. I'll reveal the solution in 3, 2, 1. Find the total distance by adding every part of the journey. 60 plus 80 plus 20 plus 30 plus 40 equals 230 kilometers. So the total distance traveled is 230 kilometers. Now, let's find the displacement. Compare the north and south movements. The ship travels 60 kilometers north, then 20 kilometers south, and another 40 kilometers south. That's a total of 60 kilometers south. So the north and south movements cancel each other out. Next, compare the east and west movements. The ship travels 80 kilometers east and 30 kilometers west, leaving a net movement of 50 kilometers east. Since there's no remaining north or south movement, the displacement is simply 50 kilometers due east. So our final answers are total distance equals 230 kilometers, displacement equals 50 kilometers, direction equals east. Don't forget to subscribe and turn on notifications for more simple physics lessons. See you in the next video.